Mars has long been one of the most studied planets in our solar system. For decades, NASA has sent orbiters, landers, and rovers to explore its surface, searching for signs of ancient water and possible life. However, among the thousands of images transmitted back to Earth, some photographs have sparked intense debate. Certain formations appear unusually geometric, almost as if they were shaped intentionally rather than by nature. NASA typically explains these shapes as the result of erosion, wind patterns, and the human tendency to see familiar shapes where none exist, a phenomenon known as pareidolia. Yet some independent analysts argue that pareidolia cannot fully explain structures that show symmetry, sharp angles, and repeating patterns across different regions of Mars. One of the most discussed examples includes tunnel-like openings and cavern entrances that appear deep enough to shield against radiation, making them potential habitats for microbial life. NASA has acknowledged the existence of these lava tubes, but has provided limited details about their depth, internal structure, or long-term exploration plans. This has led to speculation that Mars may not be as lifeless as officially portrayed, and that certain discoveries are being carefully framed to avoid premature conclusions. Adding to the mystery, several high-resolution images released in the past were later removed or replaced with lower-quality versions without detailed explanations. While there is no confirmed evidence of artificial structures on Mars, the unanswered questions continue to fuel curiosity and skepticism among researchers and the public alike. As exploration technology advances, future missions may finally provide clearer answers about what truly lies beneath the Martian surface. Europa, one of Jupiter's largest moons, has become one of the most intriguing objects in the search for life beyond Earth. Beneath its frozen surface lies a vast ocean, hidden from view, but revealed through gravitational and magnetic data. Scientists estimate that this subsurface ocean may contain more liquid water than all of Earth's oceans combined, making Europa a prime candidate for hosting life. NASA has confirmed the presence of water vapor plumes erupting through cracks in the ice, ejecting material from the ocean into space. This discovery was significant because it suggests that Europa's ocean is not completely sealed, potentially allowing future missions to sample its contents without drilling through kilometers of ice. Despite these promising findings, discussions about life on Europa are often framed cautiously. NASA emphasizes habitability rather than confirming any biological activity. Some researchers believe this cautious language reflects the immense impact such a discovery would have on science and society. Europa's ocean is believed to be in contact with a rocky seafloor, where chemical reactions could provide energy sources similar to hydrothermal vents on Earth. On Earth, such environments are known to support life without sunlight, relying entirely on chemical energy. Yet missions designed specifically to explore Europa's ocean directly have faced repeated delays and limitations. Some speculate that technological challenges are not the only reason for these delays, suggesting that the implications of discovery may play a role in the pace of exploration. Europa remains a silent world, hiding its secrets beneath kilometers of ice, while humanity watches and waits for the moment its mysteries are finally revealed. Enceladus, a small icy moon orbiting Saturn, surprised the scientific community when powerful geysers were observed erupting from its south pole. These geysers eject water vapor, ice particles, and organic molecules directly into space, offering rare access to the moon's subsurface ocean. NASA's Cassini spacecraft flew through these plumes and detected complex organic compounds, including molecules associated with the chemistry of life. The presence of these compounds suggests that Enceladus possesses the essential ingredients needed to support microbial life. In addition to organic molecules, scientists also identified hydrogen in the plumes, indicating active chemical reactions occurring at the ocean floor. On Earth, similar chemical reactions occur around hydrothermal vents, which are known to host rich ecosystems without sunlight. Despite these groundbreaking discoveries, Enceladus has not yet been the target of a dedicated life detection mission. Some researchers question why a moon with such strong indicators of habitability has received less attention compared to other celestial bodies. NASA often cites budget constraints and technical challenges, but speculation remains that the implications of discovering life may influence mission priorities. Enceladus continues to eject material into space, silently offering clues to one of the greatest questions humanity has ever asked. Are we alone? Images are among the most powerful tools in space exploration. A single photograph can reshape our understanding of an entire planet. Over the years, NASA has released millions of images to the public. However, careful observers have noticed that some images later appear altered, blurred, or replaced. In certain cases, high-resolution images showing unusual surface details were replaced with lower-quality versions without detailed explanations. NASA typically explains such changes as routine data processing, calibration issues, or the need to remove noise from raw images. While these explanations are scientifically reasonable, they have not stopped speculation, especially when altered images involve symmetrical shapes or structured patterns. Some former contractors and analysts have claimed that certain image details were intentionally minimized to avoid public misinterpretation. From NASA's perspective, releasing ambiguous images without context could fuel misinformation and conspiracy theories. However, critics argue that transparency builds trust, and that withholding or altering images may have the opposite effect. These image controversies highlight a deeper issue: the balance between scientific responsibility and public curiosity. As technology advances and independent researchers gain access to raw data, it becomes increasingly difficult to control how information is interpreted. The question is no longer whether anomalies exist, but how they are explained, and who gets to decide when the public is ready to see them. The discovery of extraterrestrial life would be one of the most profound events in human history. It would challenge our understanding of biology, philosophy, and our place in the cosmos. Some experts suggest that the reason NASA and other space agencies communicate cautiously is not because evidence is lacking, but because society may not yet be ready for such revelations. History has shown that humanity often reacts with fear and skepticism to paradigm-shifting discoveries, from heliocentrism to evolution. The possibility that Mars, Europa, and Enceladus could host microbial life forces us to reconsider our uniqueness and vulnerability as a species. Some argue that revealing life too early could destabilize societies, influence religious and philosophical beliefs, and provoke unintended consequences. Yet curiosity is intrinsic to humanity. We seek answers, explore the unknown, and imagine the possibilities beyond our world. NASA's cautious approach reflects a balance between responsible disclosure and the public's right to know, highlighting the tension between transparency and prudence. Ultimately, the mysteries of Mars, Europa, and Enceladus remind us that the universe is far more complex than we imagine, and that some answers may only come with time and careful exploration. As we continue to explore, we are faced with a choice: to fear the unknown or to embrace it with curiosity, science, and an open mind. The universe has always kept its secrets. Now, the question is whether humanity is ready to finally uncover them.